This time, dy dx is y prime. So you have y prime and y both having power of 1. So it must be first order linear. Now for first order linear, remember the standard form is y prime plus px, y equals to qx, right? And the formula for the multiplier is m of x equals to e to the px integrated. So those two are the formulas you should use. So you must remember these two things. Okay. Now if you compare this given equation with the original formula, you see that y prime here has only 1 as its coefficient, whereas you have x squared plus 1 as its coefficient. So in order to harmonize the two, I better divide everything by x squared plus 1 to be able to use that. Okay, so you have y prime plus 3x over x squared plus 1 y equal to 6x x squared plus 1. Then we can say that this is our px, and that's the qx. Therefore, in order to find out the multiplier, we have to take e to the integral of 3x x squared plus 1 dx. And in order to integrate this, it's very useful to know the following integration formula, which is integral of f prime over f dx is. Does anyone know the formula for this?
ln of x?
Now, ln of the denominator, right? It's the ln of the denominator. So using that, let's see if we can make use of that. If you differentiate x squared plus 1, what do you get? You get 2x, not 3x. Well, but that's just a constant multiple. We can always try to pull the constant out. So let's try to do this. 3 is a constant multiple, so I can pull it out. And if I do that, I'm just left with x over x squared plus 1. But since derivative of x squared plus 1 is 2x, I really want a 2 here. So I put the 2. And I must have borrowed 2 from somewhere. From where? Here, right? So by borrowing the 2 and putting it here, I now have f prime over f, right? If you're unsure how this is same as that, just try to simplify this. So you have 2 and 2 cancels, and if you put the 3 inside, you get exactly what you had before, right? Therefore, these are really the same thing. And we have e to the 3 over 2 ln of x squared plus 1, because the formula says it's a log of the denominator, and the denominator is x squared plus 1. Now, it's ideal if we can simplify this further, and the way we simplify this further is by getting rid of, moving this 3 over 2 away, because in order to simplify, you want to cancel the e and ln, but right now you can't cancel the e and ln because of this 3 over 2, right? So we want to take this number in front of the log and jump it over the log, like a frog. I like to call this rule as frog over the log rule. The number that jumps over the log like a frog. Like that. And now I can happily cancel the e and ln, which gives you x squared plus 1, so 3 over 2. Okay. Now, we've just managed to know where to start. This is just the beginning. We just figured out what the multiplier should be. What do we use for this? Why did we care to figure this out? It's the multiplier. We multiply this to the original equation. Not the original, but the one that we made to the standard form. So we multiply this to the standard form. Let's multiply it. So we have x squared plus 1, 3 over 2, y prime, plus x squared plus 1, 3 over 2, multiplied to 3x over x squared plus 1, y prime, and then x squared plus 1, 3 over 2, multiplied to 6x over x squared plus 1. Sorry, it's a little confusing here. So that's what you get. And the sole purpose of multiplying the multiplier is that, oh, sorry, this shouldn't have y prime there. Okay. The sole purpose of having such a thing is so that the left side turns into the product rule. It'll be the derivative of this thing, right? So this entire thing looks pretty similar to this first part, except that instead of having prime attached only to the y prime, it should be done to the entire thing, right? So this entire left side turns into this. And of course, if you're good with differentiation, it will be nice to check that this is indeed what you get. But if you're not too sure, then let's just write it down and just believe in it. Okay? So have faith, right? Yeah. Just like believe in religion. Have faith and just move on, right? Okay, and then you have x squared plus 1, x squared plus 1, you can cancel them. You have x squared plus 1. See, this is power of 1, and if you have the same base, when you divide, it's same as subtracting the exponents, right? So 3 over 2 minus 1 gives you 1 over 2 times 6x. Now we can integrate both sides. Now the left side is easy because you differentiated and integrated, and they're opposite operations. So when you do the two things in sequence, you come back to what you started with. So that's what you get. So in other words, integration cancels the differentiation, and you get right. On the right side, x squared plus 1, it has the derivative 2x, which is a multiple of 6x. So that suggests that we should be integrating the right side using the substitution. So set u equals to x squared plus 1. That makes du equals to 2x dx. And therefore dx is du divided by 2x. And that takes care of almost everything. So first, u is x squared plus 1, so you set u 1/2 power. And then you have 6x, and since dx is equal to 2u over du over dx, du over 2x. The x's cancel. The x's cancel, and 6 divided by 2 is 3. So that gives you 3u to the 1/2 power du. And you do the integral by the power rule, which says you first have to add 1 to the exponent. What's 1 plus 1/2? 3 over 2, right? And put the reciprocal of this in front, so 2/3 goes in front. I had a 3 before. 3 cancels, and you get 2 times u to the 3 over 2. And since u is x squared plus 1, that gives you 2 times x squared plus 1, so 3/2 power plus c. And then to finish off this, you should divide this to the other side, and you get y. When you divide this to the other side, this cancels, so you're left with 2 plus c divided by x squared plus 1, 3/2. So that's the final answer. Where you have this c, if you had an initial condition y of 0 equal to something, then you would be using that to figure out what this c is. But since I didn't give you any initial condition, this will be the final answer.